Okay, so let's get into this. Our sources today are maybe the most wonderfully unexpected material we've ever covered.
I think that's safe to say.
We're not looking at, a dense economic report. Instead, we're diving into the world of gravity and griddles, Remy Rocketboots, and the pancake planets.
And this is such a perfect deep dive for you, the learner, because our mission here is to take this completely whimsical story and pull out some really solid physics principles from it.
Right.
It shows that something complex like orbital mechanics doesn't always need a textbook. Sometimes all you need is a really good, if slightly absurd, analogy.
I love that. We're using cartoon physics to understand actual gravity.
Yeah.
So let's jump in. The setup. We start in a place called Syrupville,
Yeah.
and we meet our hero, Remy Rocketboots, whose life is pretty normal until one morning he's just making breakfast.
That's it. And that's where the deep dive really begins, with this moment of unintended scientific consequence. Remy does this one incredible pancake flip.
And the source just says POF.
A single star emoji and everything. One pancake flew so high it didn't come back down. It basically achieved a kind of escape velocity.
He's just launched breakfast into low Earth orbit. The pancake planets are born, and the system is immediately unstable.
Right away. That single flip creates the core problem of the whole story.
It's what happens when you introduce motion without, thinking about the laws that govern that motion.
Yeah.
He just launched it, completely ignored gravity.
And now the entire celestial neighborhood, the Batterverse, as they call it, is spiraling into breakfast-themed chaos.
It's a crisis.
A massive crisis. And the description of it, while it's funny, is actually a great illustration of what happens when angular momentum just goes completely wrong.
The details are so vivid. You've got fluffy pancakes spinning like they're Saturn's rings.
Which they shouldn't be, not if they're individual planets.
Exactly. Then there are blueberry pancakes beeping like little satellites.
Yeah.
And my favorite detail, a chocolate chip pancake that's just broadcasting jazz music from space.
It sounds fun, but from a physics perspective, it's a complete mess. A terrifying mess, really.
Because it wasn't just weird, it was getting dangerous. The pancakes started drifting apart, leaving these sticky syrup trails.
And that shows there are no stable orbits. They were even crashing into weather balloons. The whole system is just completely unstable.
And Remy's reaction, his immediate fear, it really captures the stakes here. He realizes, if I don't figure out how to balance them...
There's going to be a breakfast-based black hole.
Okay, that line about the breakfast-based black hole, it's funny, but it's also a pretty good analogy for gravitational collapse, isn't it?
It's a perfect analogy.
So wait, is the source implying that the combined mass of all these pancakes, all chaotic and unbalanced, would just start collapsing in on itself?
Precisely. In any system like that, if the objects don't have enough velocity moving sideways to counteract the gravitational pull of their collective mass, the end state is always implosion.
The chaos couldn't last? The forces weren't balanced?
Not at all.
This whole scenario feels a lot like what happens when you're trying to learn a huge new topic.
Oh, absolutely.
If you don't grasp the underlying structure first, the core principles, everything just feels like it's drifting away or crashing into each other. It's information overload.
It's your own metaphorical gravitational collapse. You need to find that structure, and fast.
And that's what drives Remy's mission. He has to physically go out there and correct the physics.
Which brings us to the adventure. He can't just wish it better.
Let's talk about his gear for a second, because the tools he uses are important later. He's got a whisk-shaped walkie-talkie,
a spatula for a helmet, and my personal favorite, jet-powered oven mitts.
See, they're not just props. They are all tools for applying force and, achieving stability.
And his ship, a syrup-fueled hover skillet, takes him out there to really see the scale of the problem.
He's flying past places like Maple Mercury and Peanut Butter Pluto. It's a whole breakfast galaxy.
It is. And we even get that great moment with the waffle moon.
Right, where it just yells at him, "Go away, you flaky flipper."
But all of this is just the journey to find the expert he needs.
He gets to the heart of it all, the pancake galaxy core, and he meets the Griddle Guardian.
A talking frying pan with a monocle.
Of course. And the Guardian, who is the voice of scientific reason here, gives him the diagnosis right away.
And what's so interesting is that the Guardian doesn't blame him for the flip itself. He blames the ignorance. He says, you launched them without understanding gravity.
The problem wasn't the action, it was the lack of planning for the reaction, the lack of a counterforce.
Exactly. And that leads to this key moment, the question from Remy, that basically contains the entire scientific answer we're looking for.
He's finally getting it. He asks, wait, so if I stack the pancakes just right, Their mass will keep them balanced.
And the Guardian confirms it. Exactly.
So the whole solution is about understanding that relationship. Mass, distance, and the velocity you need for a stable orbit.
And right there, the story shifts. We move from the whimsy into a really clear explanation of orbital physics.
Which is where we get to the core of this deep dive. Mass, motion, and gravity.
The source is very explicit here. It lays out the fundamental physics of why planets stay in orbit.
Okay, let's break that down using the Guardian's lesson. So planets stay in orbit because of a balance between two opposing forces. Force number one is obvious: gravity.
Right, the force pulling everything inward toward the center of mass.
And force number two is motion. It's what keeps the object from just falling straight into the sun, or the center of the griddle.
But we need to be a little more specific than just motion. It's really about inertia. It's the object's tangential velocity. It's forward speed.
So it's constantly moving forward fast enough that, as it falls, it misses.
It misses. Orbit is basically a continuous state of falling and missing. It's an active fight between being pulled in and flying away.
And Remy's solution shows how you manage that fight. He uses his spatula jet to physically nudge each pancake.
That spatula jet, in our analogy, is him applying the kinetic energy. He's adjusting that tangential velocity to get the balance just right.
And he had to account for the different types of pancakes, right?
Yeah.
This sort of makes a really clear distinction there.
A very clear one. It all came down to mass and distance.
You had the dense, syrupy pancakes on one side.
And the really light, fluffy ones on the other.
So the syrupy ones had more mass.
Much more mass, which means they exerted a stronger gravitational pull. So to stay stable, they had to orbit much closer to the core.
And the fluffy ones, the low mass ones.
With less mass, they had a weaker pull. So for them to be stable, they had to float much farther away. If they got too close, the core's gravity would have just sucked them right in.
That is such a great way to visualize it. Less mass means you need more distance or more speed to stay in a stable orbit.
It's all about tuning those three variables.
Right.
Mass, distance, and velocity. The source makes it really clear that while the mass is fixed, velocity is the thing Remy has to actively manage.
Though I have to ask, doesn't a syrup-fueled skillet kind of complicate the idea of a frictionless vacuum? The need for constant thrust seems to go against the idea of inertia.
That's a great point, and that's where we have to remember it's an analogy. The syrup trail and the jet are really just stand-ins for the idea of energy input.
Ah, yeah.
It's a way to show that achieving and correcting that velocity isn't free. It requires work. It's a narrative device to hammer home that speed needs energy.
And they even throw in that great little detail about spin. Remy gives Peanut Butter Pluto a whipped cream hat for better spin balance.
That's angular momentum made delicious. It's showing that stability isn't just about orbit. It's also about the rotation of the body itself. You can't have it tumbling through space.
So as we boil this all down to the foundational nugget of knowledge for you, the listener, what's the core formula from the Girdle Guardian?
It's stated very clearly. Bigger objects have more mass, which affects how they orbit and how much gravity they produce. Mass dictates the gravity, and that gravity must be perfectly balanced by velocity and distance.
It's incredible. We went from a complete breakfast disaster to a really clear understanding of celestial mechanics.
Which brings us to the final synthesis, because the story gives us both a science takeaway and a life lesson.
Right. Remy gets back to Syrupville, he saved the Batterverse, and he puts up a sign.
The conclusion to our deep dive, really. He writes on the town science board, mass plus motion orbit. Even pancakes obey physics.
It's just a great, simple summary of a universal law.
But then there's the life lesson, which is just as important. The source points out that even silly ideas can teach you something profound.
If you approach them with curiosity, yeah, the absurdity of it all actually makes the lesson stick.
And think about this. What if Remy had never made that mistake in the first place? The source suggests that sometimes a mistake, a moment of chaos, is what forces you to learn.
The crisis was the catalyst for his own deep dive.
It launched him into learning something amazing.
So for you listening at home, the takeaway is that finding joy in these really unexpected sources can be a powerful shortcut to knowledge. Embedding that formula, mass plus motion orbit, inside this crazy story makes it unforgettable.
Absolutely. The adventure provided the context that made the science stick.
So a culinary catastrophe becomes a perfectly balanced mini solar system. And the source reminds us, pancakes are not scientifically accurate planets.
But they are a fun way to understand orbital balance. And that idea of balance of opposing forces, that's the real core takeaway for any system, not just planets.
The power of a simple analogy. It's a good reminder to be creative in how we approach learning.
But the source doesn't just end there. It leaves us with one final provocative question for you, the listener. It invites you to use the knowledge you just gained.
A great way to lock it in.
The challenge Remy poses is this. If you created your own pancake planet, what would it be made of? Banana craters, syrup rivers, jelly bean volcanoes.
Draw your breakfast universe and remember, science is delicious.